My name is Kregg. I'm a manufacturing applications engineer with GoEngineer, and today I want to go over some tips and tricks that I feel you should know and possibly even be using. It's meant to help speed you up, make things more automated so you're not repeating the same mouse clicks time and time again when there may or may not be a setting for that. So let's go ahead and get started. Alright, the first thing we're going to go over is some of the basic settings. Now, the quickest way for me to get to my CAMWorks options would be to right click on this CAMWorks NC Manager and select Options. So the first thing we're going to start out with really would be in our Update tab. I'm going to be running Extract Machinable Features, and this Add New Features to Feature Tree is one that gets a lot of people. It can be a little bit frustrating when you don't know what's going on here. So I'm going to leave this selected and we'll come right back to that. So I'm going to go ahead and run this Extract Machinable Features, let it find all the setups. And there are 6 setups for this part. So here we have all the 2.5 axis features that were found. I'm going to go ahead and generate the operation plan. So the idea is, what if we decide during our programming that we actually don't want some setups or want certain features? Let's say that I go and delete a couple of these here, these setups. If I delete these and leave them here in my recycle bin, then Extract Machinable Features will ignore them. It'll assume that we don't want these anymore. So if that's the case, if I just want one setup like this, this is a quick way of doing that, is leaving the features that were found on the other setups right here in the recycle bin. So if I go back and run this Extract Machinable Features, these won't continue getting populated. The other method would be if we just wanted to do one setup at a time. I'm going to go ahead and get rid of this as well. Because on a part like this, if we're not trying to do all the setups, that can be a little bit overwhelming to get all of those features or have to end up removing them anyway. Let's assume that I just want to start on this face and I'm not really trying to get any other setups. So what I would do in this case is I'd create a mill part setup, and instead of running Extract Machinable Features here, because up here these options are global, they apply to the entire part, the entire setups. So what I would do instead is I would right click on the setup that I just made, and I'd use this Recognize Features. So essentially that's running the Extract Machinable Features, but just finding the features for this one setup. That way it's not generating all those extras that I'd have to go through and remove. So now I want to show you essentially the first option and why that's it can be kind of annoying for some people when they're not sure what's causing the problem. A scenario would be if we decide we want to add a couple of features ourselves. I'm just going to add like a pocket feature. And let's say I want to go back and make a change to the part. Doesn't matter where at. Anytime that we go back to our SOLIDWORKS tab, and even if we don't make an edit, even if I just go into this to a feature and don't change anything, just by going in, it triggers a rebuild. So if I go back now to my feature tree, it's going to see that something happened. We went into a feature. It doesn't know yet that whether or not something's been changed. So I'm going to let it rebuild. So it's going to compare itself against anything that might have been changed. And I'm going to check my options one more time here. So yeah, so I've added new features in or to the feature tree. Otherwise, they're added to the recycle bin. So what this is going to do is when we make a change, all of a sudden people will say, well, there's like 6 features that just popped in, or I just removed them and they keep popping in. Well, that's what's actually happening, is they have that option so that anytime that the extract features runs again, it's going to find all the features again, and of course unless you leave it in the recycle bin. So typically I leave this deselected, and that's because I control it with the recycle bin. Essentially, I just leave the features in the recycle bin that I just don't want to repopulate. But on the same token, if you do leave them in the recycle bin and wondering why it's not generating a feature, that's why. So while we're here, it's important to take care on how we're going to apply this change. Any changes that we make on any of these tabs, they're applied at a different level. What I mean by that is down here in this corner, this apply to, right now it's set to all possible. So that would essentially mean it's going to apply not only to this part, but all the parts moving forward. If I make a change that's particular to this one part, I'm going to want to use this the drop down and select active document. That way it doesn't affect the settings that I want to essentially be default. But with a setting like this, I want it to remain, so I'll leave that at all possible. I'm going to run extract machinable features just for this first setup one more time. And another thing that people get caught up on is when we're editing an operation, what the preview button, what it does. And some people aren't even aware that they can select that. So I'm just going to generate the operation plan, and I'll generate toolpaths as well. And the preview button is something that I rely on constantly. Essentially what it's doing is instead of right-clicking on an operation and selecting Generate Toolpath, when we edit an operation, if we select this Preview button, that would be the equivalent to say Generate Toolpath. So what that means is if I make a a change, regardless of maybe my step over, I want to make that 30%. If I select this Preview button, I'll get an update in the toolpath to actually see what it looks like. So in that scenario, once I select OK, there's no need to go back and generate this toolpath again. I've already selected Preview, which is the same as right-clicking and say Generate Toolpath. And one thing that we have an option that kind of handles how that process works. I have it set to default, which is so in our options in this update tab, it's this update toolpaths when parameters change. So what this is saying is even if I don't select preview when I make a change, once I select the OK to accept any change that I make, maybe I go here and I say 25. If I don't select preview and I just select OK, it's going to generate the toolpath. So I leave that to default because I want it just to double check myself, and so I have that set to always. Now there is an extra option for 3-axis toolpaths. Again, it's just how you maybe are familiar. Maybe you always select preview. In that case, you wouldn't need this. I would set this to never. If you're more familiar with just selecting OK, then you might just want to set this to always. So that's going to be something that you'd want to change kind of in accordance on how you already your workflow is already established. Now, another thing that a lot of people don't know, because it's fairly new, starting in CAMWorks 2020, instead of now saving an operation or a strategy rather, so essentially if we're going to our features here, we have this rough rough rest finish strategy. Instead of saving a full strategy, we can actually save an operation now. And what I mean by that is, let's take this rough mill for example. Let's say that all the time I'm using a very specific amount of settings, or at least close enough to give me a better starting point. Maybe I'll say 27% step over. Maybe I'll do a 0 allowance, and then for my depths of cuts, maybe I'll say 50 thousandths. And then that's good enough for now for what I want to show you. So let's say this is a fairly routine. These settings are fairly routine for me. I don't want to have to keep doing this over and over and over again. What I'm going to do is, if I go to this Optimize tab, down in this corner here, where it's the TechDB here and the operation parameters, I can now do a save as defaults. If I do that and say my roughing op, I can do this create new. If I already have one existing and I just want to override it, I can use that as well. So now, at any point in time, I can go right into an operation, select this load defaults, and from the drop down I have this my roughing op. So to show you the benefit of that, I'm going to go to an operation here that this is just from the TechDB. I haven't changed any settings in this one or modified it in any way. All I need to do is edit the definition in our Optimize tab. I'm going to go right to that load defaults, select my roughing op, and now when I select the preview, it now loads all those same settings. So again, back when I was programming, I used to be a machinist. I was repeating the same clicks over and over and over, and my goal is that if I can help somebody not have to do that, that makes me happy. So that's essentially why I'm going over this now. So one other thing I wanted to point out is, by default, when we select the preview button, the dialog window here collapses. It's meant to just give you a little bit more of a view of what's going on, like the part or the toolpath. Personally, I don't like that. I prefer it to stay open, so that if I'm in a tab and I'm setting or changing a setting, I want to quickly select preview and then be able to go right back to where it was in case I want to make another modification. So what I do is, in our options, again I right click on the CAMWorks NC manager and then options. In my display tab, it's this collapse operation on dialog preview. That's the setting that's causing that to collapse. Anytime I teach a class, I have them remove that checkbox. It just makes things a lot more streamlined. So that's probably one of my favorite settings, is simply that one. So now when I select preview, this will stay. Okay, so now I'm going to switch over to another part, which would be to show you some feed-based colors, as well as using a high-speed, kind of a high-speed option in our roughing. So I've already got the toolpath on here. In our options, in this display tab, we have this use feed-based colors checkbox. And if I select, if I select this option and I can select edit feed colors, I can put in my own values and I can choose my own colors. So I've already set this up just using these two. So if I go to and click on my first rough mill, which is, I'm using a volume mill toolpath, we can see exactly where the rapid moves versus the feed moves are. Again, the red would be above 75 inches a minute, and the orange would be less than that. So this really helps kind of give you a breakdown of what's going on. Normally, you would just see, solid lines with no difference in color. The next I want to talk about is doing a rough mill with either essentially the pocket in or pocket out strategy. As you can see that we just get these sharp corners, and that can be hard on the tool, can be hard on the machine, it can produce chatter. It's not always a good thing to go to a sharp corner. So one thing we have to alleviate that would either be we could do like a volume mill, which is the one that I had earlier, or what we can do is utilize this high speed option. So if I go in here, I can actually say I don't want sharp corners, I want round corners. Maybe I'll give it a max radius of 0.1, and then links. So essentially anytime that it has to move over to the next path, if you can see right here, this line. So instead of making just a hard straight line, I'm going to let it do an S curve. So you can see in this picture here, now it'll just blend, it'll keep moving, and just have a much smoother transition to the next step over. So now, if I go ahead and select this preview again, we now see the rounded corners, and then we see the S move. So instead of a straight line, it's now a lot more streamlined, flows a lot better. Alternatively, if we want the sharp corners, let me take this back to default here. We do have the option of slowing down the sharp corners. So if we're in our feed and speed tab, I can use this enable corner slowdown. So if I select this, you now actually see two colors. So orange for where this slowdown is happening, and then red for any of the straight lines that are more than 100,000th in length. Likewise, if we do round the corners, we can also slow down the corners using the arc feed rate. So just a little bit more flexibility than what a lot of people are familiar with. Okay, and sorry, I apologize if I'm moving fast. I just have a lot that I want to get through. So again, if you do have questions, please go ahead and ask, but I'm going to wait till the end to answer the questions. The next one I'm going to get to is this using flowline for a pattern project. So pattern project is a 3-axis toolpath. It's a finishing, meant for finishing. This one is has several different options as far as the pattern is concerned. So in this pattern right now it's just set to slice, which is the default, but we have several more options. And then lastly, the flowline. Flowline is a powerful tool in that we can use it not only to blend two curves together, but also to act essentially as a contain area. So when I select flowline, I now have the option curve 1, curve 2. If I go into my curve 1, I'm going to select my curve 1, and again, another thing worth mentioning is I actually created a sketch. You don't have to create a sketch, you could use the part geometry, but for a long time I didn't actually know you could use a sketch, and I wanted to show that in this example. So all I did was just draw a straight line across. So rather than following the geometry's edge, I just went ahead and created a couple sketches. So I've got two sketches, curve 1 and curve 2, so straight across from one another. And what this is going to do is blend the toolpath in between those two. So again, now if I select preview, so we see that it's blending it in between those two edges, and it's also keeping the toolpath within those two edges. So essentially it's acting as a contain area as well. So the question would be, well, what if we needed to go a little bit further over? Because right now it's staying fairly high. We can offset these curves. So if I go back into my curve, I can utilize this offset, and I can go out just a little bit further. Depending on the diameter of your tool, you can offset it, however amount to get it to go further over. So if I offset that just by about 200 thousandths, we'll be able to see it, the tool will be able to drop down much further. So the other thing would be, I've got two other curves to show you as well, to show you just how this responds to the curves. So I'm going to go back to my curve 1 and select a different curve. I'm going to choose curve 3. So essentially it's the same geometry, but I've just stopped it short. So it's only it terminates right here. So again, my curve 2, I'm going to choose curve 4, and then I'll preview that, and this will help kind of explain how it's acting as a contained area as well. So in essentially both directions, X and Y. Again, it's a powerful tool. I feel like a lot of people aren't using it to its full advantage. So that's one of the this is one of my favorite options with Pattern Project, and I use that when I can. Okay, so we're going to go on to the next part. So another one that another thing that I show a lot of people is the use of just one feature to be able to add multiple operations. So I've got this this multi-surface feature, and the important part here is to set the feature type to all displayed rather than faces or surfaces. So I've just got this all displayed so that, you know, the software is looking at the entirety of the part. And I've generated a constant step over, and again, because it's all displayed, it's just going, you know, it's machining the whole thing. But I can start adding a few other operations to this if I wanted to break this up a bit. For instance, I'm going to add a contain area to my constant step over here. I have a couple that I've already predefined, so I'll let this recalculate. Now, a part like this, you may end up wanting to use a constant step over and a pattern project, or even a Z level. Sometimes you can't really get away with just using one 3-axis finishing method to get a streamlined toolpath. So essentially what I can do is, I don't have to go back and create a new feature, I can just keep adding operations. The easiest way to do that is if I right click on the constant step over, I go down to my 3-axis mill operations. So here I could add Z level, I could add a pattern project. I'll go ahead and add a pattern project in this case. And then what I'm going to do is, or all I need to do is just create its own contain area, or a void area in that matter. So I'll say new contain area. I'll use, and again, I've just predefined some sketches. We could use the geometry of the part as well. I'll just generate the toolpath with the default settings here. So essentially I could go through and machine this entire part just with utilizing one feature and contain and avoid areas. The other thing that can be helpful is using our control key to be able to copy an operation. So that's what I do a lot of times with, well, in a lot of different scenarios. All I do is I select which one I want to copy, I hold down my control key, and then I click and hold down my mouse, and then I drag it. And then once we get this icon, this little enter key and the plus symbol, I can let go of my mouse, and then I can let go of the control key. And now I have a constant step over 1 copy, and it does copy everything including the contain area. So all the settings that would be inside this operation are matching this one perfectly. So I can make however many copies of this I want, and just kind of change the area that it's machining in. Okay, so yeah, I've got to move a little bit quicker here, guys. So another one here is going to be the stock definition. I'm going to start with this one first. This one comes up a lot. And this scenario happens when our SOLIDWORKS coordinate system for the model is not in the same orientation as how we're going to set this part up. So machinists, we see this thickness as Z, so Z would essentially be facing up. But a designer, that's not their concern, and it shouldn't be their concern. So what happens is when we go into our stock manager and we're going to use this bounding box, if I want to add stock in X, if I just start selecting the up arrow here, it's not going along the sides like I would expect it to. It's actually going up in Z. Well, the reason being is, as you can see here, it's just set to use the SOLIDWORKS coordinate system here. So the option that we have to fix that would be in our coordinate system drop down here. I've already created a coordinate system, a SOLIDWORKS coordinate system. So here I have it in this available list. If I select that, you'll notice that this has now changed my XYZ, and now the stock is in the direction that I would expect it to. So that one does come up quite often. Let's see. Okay, I got one more part I want to show you. So this is going to be utilizing a work in progress for our stock. So essentially using an STL file. So the scenario in this case would be if we have a lathe and a mill, but not a mill turn to be able to have live tooling. So essentially what we're doing is we're going to turn this to the OD profile, but then we're going to take it to a 4th axis mill to be able to get some of these other features. But what I want to do is I want to be able to start with the profile that the stock profile that I'm left with after we turn this. So essentially what I've done is gone ahead and put some turn toolpaths on just on this OD. And once we have that, and so real quick, let me show you one other thing before I get to there. I'm going to go and edit the stock manager here. And one thing that I've done is I've created a configuration for this part as well. A SOLIDWORKS configuration, that is. So in our configurations for SOLIDWORKS here, I've got stock profile, and just show you what that looks like real quick. So it's kind of a blank that's been machined down slightly. So we're trying to go for accuracy, and so what I'm going to do is in my stock manager, I'm going to select this far right icon, the part file, and instead of using just the par file, I'm going to select current part. And when I select current part, I can actually choose a configuration. So if I set it to default, then it's just going to look like the part itself. But I'm going to select that stock profile configuration, and that's going to give me that step down here. So now that I have that, and anytime I update the stock, I want to update the operations as well. Now that I have that, I can go to my stock manager, right click on that, and I can select Save Work in Progress Model. And what this allows me to do is I could deselect any operations that I don't want included in the work in progress, but in this case I want them all. So I'll go ahead and select OK with all those selected, and I'll go ahead and save the STL. So now all I do to switch over to like the milling side of things is in CAMWorks we have our configurations. I've created a mill 4-axis configuration here. So now what I do is in my stock manager, I'll edit this, and I'm going to select this STL option here, and then I can browse to the file that I just saved, select open, and I'll accept that, let everything rebuild. So now if I just select the stock manager, we can see the leftover profile from the turning. So now as I simulate the toolpath for this part, I can see that realistically what the stock profile is going to look like. So now when I run this, it's going to give me a more accurate idea of what's going on here. So it's hard to envision kind of what's happening when the tool's buried in the stock when we're running a simulation. So that's why I really like this method, so we can actually see kind of what's happening. That's going to be it for today's webinar. I want to thank you for joining and have a great day.